iOS is safer than Android, right? Well, maybe. Welcome to Tech First with John Koetsier. So we often think of iPhones as safer than Android, right? Getting on the iOS store is harder than getting on Google Play. There's more scrutiny of apps and what they do, their code, those sorts of things, their functionality. But now, for the first time ever, security researchers have found an ad fraud network on Apple iPhones that uses click injection to steal potentially hundreds of millions of dollars. It's in over 1,200 apps with billions of downloads, has been since mid 2019. We're talking apps like Talking Tom and Asphalt 9 is in there, Pixart is in there, Gardenscapes, Helix Jump, many others as well. It works by spying on your activity on the phone. And to learn more, we're going to chat with the man who found it, who is Danny Grander, co-founder and chief security officer at Snyk. Snyk is a digital security company. Welcome, Danny.
Thank you, John. It's good to be here.
Excellent. Super happy to have you here. Now, let's just dive right into it. Big picture, what did you find and what ad network is doing this?
Absolutely. So we identified an SDK, malicious component that is getting integrated into different iOS applications and get into the App Store. That's how they, getting downloaded to end users, the consumers. And so in that SDK, which is, distributed as a regular ad network SDK, something that developers can use to monetize on their apps through ads. So along with the advertisement for functionality, we identified that it has some malicious functionality, which leaks some data back to the company. But also, we, with the help of partners in the industry, mobile marketing platforms, the leading one, we identified also that they perform actual ad fraud, click attribution fraud. And this is something that we needed partners that have actual data to confirm, because what we did on our end is just reverse engineer the library that is available to any of us for download through the package manager, through CocoaPods. And so we reverse engineer, found the functionality, but we also confirmed that an actual attribution fraud is performed by the company.
So let's back up for half a second, because some people won't know what an SDK is, software development kit. What is an SDK and how does that get into an app?
So SDK is just another software component. So it's a general name for a software component that you integrate into your app, and SDK can be for different purposes. When we talk about advertisement network SDK, we typically mean a component that a developer integrates, and that component is responsible for showing the advertisement within the real estate that the advertisement network gets within the application the developer has developed.
Right. So, I mean, you could get an SDK for like integrating single sign-on with Facebook. You can get an SDK for, I don't know, some other functionality, maybe video functionality in your app. You can get an SDK for just about anything. And this one happens to be one for showing ads, monetization of your app from an ad network. What ad network is doing this?
So we're talking about a company named Mintegral. We believe it's a Chinese company. It's a spin-off out of a bigger company called Mobvista. And so that's also the name of the advertisement network. And so this is practically all we know about this company.
Interesting. And so talk about the scope here. How many apps was this in? How many installs, downloads do they have?
Right. So as you mentioned, this SDK got integrated into more than 1,200 applications. This has been happening for more than a year now. And so obviously not every application has the same popularity and the same number of downloads per month. And so we will definitely observe some small portion of the application having a huge number of downloads, while then we have a long tail of lesser download counts. But in general, like in total for all these apps, we estimate there are more than 300 million downloads per month. And just to kind of give another example is, so if we take some of the most popular apps on that list, And so you mentioned Helix Jump is one. And so just that app was downloaded more than 500 million times, have more than 500 million times in all the history. So it's not necessarily the versions that are affected. We don't have this data. The 500 million downloads is something we looked at, the vendor side, that they themselves are, sharing this data. But this gives you some, some kind of ballpark to kind of start estimating what is the number of affected, users and devices are
Yes.
here.
Yes. So this is an ad network that, I should say a malware, basically, an ad network SDK that is using a term of ad fraud called click injection.
Right.
How does that work?
Right. So what happens typically is that when you are as a developer, as a game developer, you want to monetize on advertisement. You can go and start working with one advertisement network, but what would typically happen is that you would work with multiple networks because you want to basically maximize on advertisement in all the various geographies and types of campaigns and all that. So you would integrate several SDKs into your applications. And so there would be actually another SDK that would mediate who would be in any given point, who would be the network that will be, giving the opportunity to present advertisement to the user.
Yeah.
So, in case the user was exposed to advertisement or was clicking, actual engagement, and it led to the installation, say, of another application, that advertisement network would be attributed the actual activity, the click, and they will get the revenue, the dollars for that campaign, right? And they will also share that with the developer. They will share some part of that, some with the developer. So that's what typically happens. And what happens in case of in this case is that the SDK tracks, it basically instruments itself into all the networking activity and all the open URL activity within the app and open store kind of app store activities. And so they track it. And when they see a click happening, so you as the user of the game, of the player of the game, click on some ad, they identify it. And then what they do is send another fake click from their servers to kind of say that they were responsible for that click, that it was coming from their network. So, there is some degree of sophistication to do it. Basically, you need to identify that a given campaign is in your network and in a competitor network, and only then fake the click, right? But basically, the way the industry works there is that they attribute the success, like the click, the event, to the last engagement point, to the last touch point.
Yes.
So in this case, suppose you're a legitimate network presents an advertisement, Mintegral sees that and they immediately fake another click, and so they got the attribution. And what we did to confirm that is basically we asked several partners to look at their data and see and check for two events coming from two different networks with less than 3 minutes difference between them. And so this is a very unlikely scenario to happen in real life. So this happens less than 1% of time, right? And so with this particular network, they basically identified it happens more than 20% of the time. So
to sort of summarize there, basically, when you have an app as a developer, you've got a game you send out there in the world, you want to monetize that, you want to make some money, you put some ads in there, you put some SDKs with ads in there. When people click on an ad and that they perform an action, that might be, in this case, it's installing an app. In other cases, it could be different things. Then there's an attribution functionality that happens in there, and you get credited for that ad that worked, and you get some money from that. And this SDK is basically saying, "Oh, wow, somebody did something with regard to an ad. They clicked on it, they installed something, they converted, and we're going to send another click really, really quickly, grab credit for that because it's last click attribution, and we're going to make some money from that." Now, is this the first time that we've seen this kind of attribution fraud, this kind of ad fraud on iOS?
So generally, we've seen cases like that, but not in iOS. We've seen cases. There is a case, such a case in 2017, and then a year later in 2018, in Android. And so that we've seen attribution fraud happening. This is a major, major type of fraud, apparently, that happens. But this is the first time we see such a case on iOS, and with also with this kind of technical sophistication around, the again, bypassing, getting into the App Store, and but also, obfuscating all their, secret functionality and malicious functionality, and getting into the App Store, and then, actually successfully performing this type of fraud for more than a year. So this is absolutely the first time we've seen something like that.
Interesting, because we've seen this before in Android, right? Because Android used to have a thing where a new app gets installed and it sends a broadcast on the on the device and saying, "Hey, there's a new app available," and people used to be able to grab that signal and then basically send out that click. But we haven't seen that on iOS.
Yeah, they are using, just to add to that, they've been using a method called method swizzling. It's like a technique. Basically, it's a type of function hook they perform on the central functions that responsible for communication and for click events, like open URL events. And this is something that is this is very uncommon to do for an app, basically, right? Like, they are an SDK. They were supposed to just do some very specific things, like showing an advertisement, right? But they instrument themselves in all the network communication of the app, and basically not only take this data and send the data back to their servers, but also perform the actual fraud. And one important thing to say is that functionality is running even if the SDK was disabled. So basically, if a mediation network disabled this, didn't enable this SDK, because in this particular geography you would want to use a different network, say, but the malicious functionality would be still running. So that's
so as a developer, you didn't actually maybe even choose that particular SDK. You just happen to have a mediation platform SDK that aggregates multiple other SDKs in.
So yeah, that's one case. I'm not sure if you actually don't get to choose. I think you do, but what I meant is that as soon as you integrated it for even like 1% of your audience, you want to use that, right? And you do not enable it in 99% of your audience, it will still be working and doing its thing. So that's the thing. I'm not sure you don't get to actually choose. I think you do need to choose to integrate.
Okay.
But when you did the hooking, the method swizzling, all this thing is happening, even though the iOS, that is particular SDK wasn't enabled.
So what are the privacy implications here? What is the app watching? What can it see? Obviously, it's doing ad fraud, so it's watching some of the things that you're tapping on or clicking on, so it can monetize those. What else is it doing? Can it see anything outside of the apps that it's been integrated into?
So first off, this is within the scope of the app. I want to be very clear on that. The SDK is installed within, like, is deployed within a specific app, and so that they are doing their interception within that particular app. So all the traffic that goes out of that app, they can actually instrument and intercept and leak back. It does not go outside of that, but within the app you have quite a lot of data, right? It would absolutely depend on the app, right? Some apps would have secret whatever, like chat text messages, right? Like that. Other apps might have just the number of coins you have on some game, right?
Yes.
But it's important to say that we basically seen three types of hooks, interception logics they have. One would be intercepting open URL calls. That is, when you click on the URL or when the app opens, say, a QR code scanner. So you scan a QR code, and then open URL happens. Basically, you're sent to a different URL. So that's one thing they're tracking, and they're sending back the URL and a bunch of other kind of parameters along. Second thing they're tracking is store kit event. Basically, this is when you open an app store from within the app, right? Like you have this kind of, and so, but I think the most dramatic, to your question, to the privacy violation here, is that they actually intercept all HTTP communication, all HTTP request and response, and post or GET request, but they leak back they can leak back the URL and the headers. They do not leak back the body. So that's also interesting to say, because important to say, because the functionality of leaking the body is there, but it seems like they have some sort of bug there, and so it wasn't actually doing that. But the headers part and the URL part, it's quite a lot. So first of all, in the HTTP request headers, you have all the cookies and the authentication token. So that in itself is very significant, right? So along with potential private data, right? Like depends on the app again, right? It would vary from one app to another, but it would absolutely have some sensitive information there.
Yeah.
So it's very hard to say to generalize that, but very clear that that it's we're talking about all HTTP requests headers and the URLs. So that can be
So
a lot.
basically, they know where you've clicked, what you've clicked on, where you went, and some of the details that are included in the actual functionality of that click, like you said, the post and the get parameters for those clicks. But even the bad guys have bugs, so they didn't hit the
Yeah.
body of the request.
Yeah.
I guess that's small mercies. How is something like this not seen by Apple? How is this? I mean, apps are scrutinized before they get approved, and of course, SDKs are integrated
Right.
into an app. Is it dynamically loaded after that? Is it something that Apple wouldn't see even if they were looking pretty hard? How's it get past App Store review?
Yeah, so that's a great question. First of all, historically, Apple have been doing a great job, and I think they still doing a great job around, scrutinizing the applications that get into the App Store, and their security is top notch. That's for sure. Now, how come this happens? So, this is inevitable, really. Like, it's impossible to to scan every little piece of code within every component there is for each and every app, right? And so there will be misses, right? And so and what is important in such cases is this is a cat and mouse game in the end. And what's important is how quickly you react, how well you react with for different challenges from the mouse, right? And so and this is and again, Apple been doing great on this front for a long while, but it's very hard to kind of come at this point and say, how come you missed it? It's really impossible to kind of catch all the all the evil little things that happen. They're again doing absolutely great compared to say Android, but still it's very hard to kind of find everything. And one other aspect around that is that the data was obfuscated. So you look at the SDK, it looks benign. You basically you don't see anything fishy there. You look at the strings, it all looks fine, but then you kind of start digging in and you identify that this base 64 encoded string are actually not base 64. It's some variation of base 64 encoding. When you decode it, like through the actual decoding they are using, you get some interesting strings immediately. And so that is something I would suppose that Apple would automatically flag, but they made attempts to evade simulate proxy interception or simulators on basically what is called an anti-debugging trick. So they try to identify when you as a researcher or an automated automated framework for analysis is trying to analyze the application. So it's like we're all good. The mouse is very very good, it behaves very well. But when it gets your device, it's and given a command to fully function, then when it's like does its thing.
Does it have the command to fully function? How does that happen? Is there does it phone home? How's that work?
So it's very simple. In the initialization, in the first phase, when the SDK is initialized, it gets its configuration from the server. So that configuration gives the command of, first of all, whether enable or disable anti-debugging tricks, like anti-tampering, anti-reverse engineering protections. Second, it gives a flag for each and every type of hook I mentioned. The open URL, the store kit, and the general HTTP traffic interception. So each and every one of these is a flag that it can be set, and so this also can be done statistically, right? Like it's make it harder to detect. I can choose to enable the flag for for just a portion of devices, or just one specific geography, or for whatever anything else I wish to kind of do. So
And in fact, you mentioned that as well because you said you checked with a number of attribution partners, and it was, I think, 20% is the number that you referenced. 20 to 30% or so of the cases where they were actually committing fraud. So they weren't trying to do it 100% of the time, which would be really,
that's right.
really obvious. They were
Yeah,
trying to do it at a low level, and that's probably part of the reason why they were so successful and managed to escape discovery for a year.
absolutely. Yeah, I think on that level, like the data level, I'd say, right? Like we're actually marketing, like mobile marketing platforms have the data, but it's still, they were flying beneath the radar. So when we inquired and posed the concrete question, like given a click, are there any other clicks coming from a different network within less than 3 minutes? And so you can simply query this your data, and then you should see less than 1% case. And when you see 25, and I think we've seen some 24% to be precise. So that's a significant number, right? So and you're absolutely right. They could be greedier. They could be go up for whatever 50% or all the clicks, right? Like, but obviously it's a balance they had to keep, to not be unearthed.
Yes, I have a question about Apple's new methodology around ad attribution. So Apple, of course, in iOS 14, which is coming out very very soon, is introducing SK Ad Network and deprecating to some extent the IDFA, which is an identifier on the device for advertisers. And so with SK Ad Network, which is Apple's new way of doing app install attribution, would this type of this type of adware even work?
So I think what is what will be what will be changing in this case is that at this point only Apple will have the data. So for good or for bad, right? Like they might be able to identify this kind of anomalies in the data, like the one I mentioned. But now we have multiple MMPs, mobile marketing platforms that that have the data. And I'm not an expert on advertisement industry and the architecture there, but from what I gathered, it's that would be the major change. Basically, they will be owning the data, and they will be able to identify, hopefully, right, such discrepancies, such significant anomalies within the data, and that won't be it, and it would be harder for for others to do it, basically.
Yes, yes. So how did you find it? Talk a little bit about, maybe a little bit about what you do and why were you looking for this and how did you
Yep.
find it? It seems like a really challenging thing to find and yet you found it.
Absolutely. So first of all, at Snyk, we're building security products for developers, for DevOps professionals, and application security professionals, and that's what we do. We started with a software composition analysis product that is identifying risks, security risks, malicious components in your open source dependencies, in your components that you pull into your application. We expanded to containers, and now infrastructure as code. So this is our space. Like, we analyze components that developers use in their application. Now we have a research team, a big research team, and previously we've been working mainly in the open source world. We've been, we fixed at this point, unearthed, found, and fixed thousands of vulnerabilities in open source components, basically working with the maintainers. And this, when we expanded to CocoaPods, basically the package manager, for iOS, that is where we started looking into all types of components, because in CocoaPods it's not just open source components; it can be any type of component. So this is a good example of one closed source component. This SDK, Integral SDK, is a closed source code. And so we started looking at this as well. And we found really, especially with the recent upcoming changes, like the upcoming changes from Apple around advertisement, we found some interest in looking into those. So we started looking at several, but this one in particular, caught our eye. And the more we dig, the more the bigger it became. So this was just, we've been doing that. The research team, that's what we are focusing on. We look at, open source components, looking for vulnerabilities, very common vulnerabilities in components, but we also look at closed source components and, identify anything that is not good. So that's really kind of where we started. And, absolutely, this is also where we'll be looking more for, right? Like this, the more we dug into the space, we understood that there's a lot of things happening there. It's a big world, and we have a lot to contribute there with our research, with our capabilities, looking into those components, analyzing them in masses, right? Like doing mass analysis. It's not just, taking the SDK, apart one line at a time. We can do that at scale. So we are planning to look for more such cases, and not only in the advertisement industry. You probably know, like, supply chain attacks in the last few years are in the rise. This is absolutely a problem. There is a lot of, the types of attack vary. Sometimes it's, developer's account is being taken over by some malicious actor and they insert some malicious code. Sometimes it's just, open source library appears and on the package manager, and it at some point turns malicious. So there is typo squatting attacks, basically when you name your package with a similar name to a legitimate package. So so the developer is basically unknowingly installs the wrong package because he had a minor typo. So there is a lot of techniques that bring malicious code into the to the application of a developer. And this is absolutely one of them, when basically from the start there is a malicious intent delivering an SDK or a component to the world. So that's, I think, where also our advantages. We know and do well kind of analyzing binary code, not only open source. So that's also where we kind of it took us I think less than a week to fully disassemble this thing and understand how it works, and proceed to disclosing to Apple and moving on.
So you have disclosed it to Apple already?
Yes, absolutely. We disclosed to Apple on the 17th, and had a call with them planned. We will have another call with them. So this is already been.
What action Apple's taking as a result of that?
So we do not get updates on all their progress there, but they are working on it. They're absolutely taking this seriously. And I'm sure they will be able to comment on this later on.
Okay, excellent. What will they do in that scenario? I assume they'll be notifying developers. I assume they'll be trying to get rid of that SDK code. I'm assuming apps won't be taken down for this, because it doesn't seem like what do you think will happen?
So it's hard to say. They have several options, I guess. I don't see everything that they see, but I'd guess that they definitely would want to stop the malicious functionality, right? Like, while we speak, there is data being leaked, right? It's the functionality is there. And so that is, something, I would want to stop immediately. And, this can be achieved by removing the apps, but that's, I guess, very, aggressive.
That's kind of the nuclear option, yes.
Yes, but I guess you can, for example, reroute the DNS for these domains, where the data goes, right? So you basically on the device level can make the address that the data is being sent to, whatever, your own or just nothing,
Hmm.
right? So that won't
Hmm.
go out. And I think it does requires updates, and this is just just one idea that came to mind, but I'm absolutely not in a point where I can see all their kind of levers they can push and to get rid of this. But longer term, absolutely, they would want to get rid of these components in this app. So basically, the developers would need to deploy new versions. We'll be waiting to see what the action. We did give them a 1 week heads
Heads up.
heads up. Yep, but and it's absolutely not a huge time window to kind of
Hmm.
to act on this incident. This is how we look at it. This is an incident. This is not a vulnerability, a security vulnerability that you disclose to a vendor, and basically they can take some time to triage and understand the impact. This is an ongoing attack, right? And so
Hmm.
that's why we chose to follow a very short timeline in this case,
Yes,
and so yeah, so that's
that makes
basically.
sense.
Yep.
Yeah. So I'm trying to understand the scope of what Mintegral or Vista, which you said is the parent company, might be. What type of dollars they'd be pulling out of this? I mean, we know, as you said, it's been running since August 2019. We know that the apps it's currently in, 1,200 of them are getting 300 million downloads a month, in and around there. So that's definitely in the billions. We know that mobile user acquisition, mobile marketing to get somebody to install your app, I mean, that can easily be $3 per
Yep.
install, $5 for some high value areas. For instance, I noticed in the list of apps, there's a dating app
Mm.
in here. We didn't see a fintech app in the list that I checked that had this SDK installed, but there's going to be some that are higher leverage, and you can spend $20, $30 to acquire a user in some of those really high
Yep.
value verticals. Do you have any sense of, is it hundreds of millions? Is it potentially billions of dollars that they may have just sucked out of the ad
Mhm.
ecosystem here with this fraud?
So frankly, it's very hard to estimate from the data we do have at this point. It's very hard to even guesstimate this number. I would be also very interested to know what are the amounts we're talking about here. I'm sure the mobile marketing providers, other ad networks, can actually look at their data when this goes public, and they actually can analyze and see exactly what those numbers are, because
Hmm.
they can do the math. They know what campaigns they have, where they had the click, and then and so MMPs, the mobile marketing platforms, they can do with their help, we can kind of get to that number. But this is not something we did at this point. We really focused on the technical aspects. We were looking at software components. We analyzed this code. We found all the all the functionality there. We posting our technical blog post around it, and sharing all the factual data, factual things that we identified.
I understand. That makes a ton of sense. So you're still looking for more. Obviously, given the length of time that this one existed for, and the fact that it remained undetected, didn't get greedy and kick into case on 100% of app installs and clicks, we really don't know if there's more out there,
Right.
presumably.
Right. And that's always the case. Like, if we would not found this, we would assume there is nothing bad there, right?
Yeah.
So I maybe as a security person, I'm on the other side of that. I'm kind of, let's assume there are a lot of those, right? Same, if you look at even the COVID situation, we've been living our lives, and then this thing happens, and it's like, oh wow, apparently this thing can happen. And so what I'm assuming is, well, we'll have more COVIDs coming
Mhm.
in, and it's not necessarily a pessimistic view. It's just, I think definitely as a security person, it gets you more ready for this case. And I have no doubt this is how Apple security team is looking at this. They assume there are more such cases, and I'm sure they will be doing. They will be looking for such, and they actually have a lot of data, and capabilities to do that. So I'm sure they'll also be, having their own wins in identifying more cases. Some things that we might even not hear about, but it's that's also where they are the strongest to kind of to look and identify this.
Kind of seems you have to be both an optimist and a pessimist to be a security researcher. A pessimist that there's more bad stuff out there, and an optimist that there's more work for you down the road.
Yeah, I guess, and so yeah, like if you look at the history of any security or privacy, it's it's always there. Things are becoming more complex, and we're improving in a lot of fronts. Absolutely, yes. And but obviously, there is also progress on the other end, and fraudsters, attackers will be getting better as well. So yeah, this is the world we're living in.
Excellent. Well, Danny, thank you so much for spending so much time with me. I really do appreciate it.
Absolutely. Thank you, Jen.
Excellent. Well, and everybody else, thank you for joining us on TechFirst. My name is John Koetsier. I appreciate you being along for this show. You'll be able to get a full transcript of this podcast in about a week at johnkoetsier.com, and the story on Forbes will actually, in this case, appear very, very quickly on frankly, Monday. This is Sunday that we're recording this. So the full video will be available after that on my YouTube channel as well. Thank you for joining. Maybe share with a friend. Until next time, this is John Koetsier with TechFirst.